Lessons 1F, Acids, Bases, and Buffers. Water is defined as something that is neither acidic or basic. It's neutral. When you have pure water, there's nothing in it other than H2O. Some of that water may dissociate into H pluses and OH minuses, hydrogen ions and hydroxide ions, in even numbers. An acid or a base is a chemical in which these H ions and OH ions are out of balance. Water, therefore, is neutral. An acid is defined as a solution with high hydrogen ion concentration relative to its OH concentration, like aqueous hydrochloric acid. Due to water's polar nature, when crystalline HCl is placed into water, the positive hydrogen and negative chlorine ions dissociate and are set free from one another, increasing the number of free positive hydrogen ion numbers, while doing nothing to the negative hydroxide ion concentration. More H plus compared to OH minuses makes it an acid. In fact, almost all of solid HCl when placed in water dissociates into its ions H plus and Cl minus. This makes hydrochloric acid a strong acid. H2CO3, carbonic acid, on the other hand, is not a strong acid. And when solid hydrogen carbonate is placed in water, only a fraction of it dissociates into positive hydrogen ions and negative HCO3 ions, leaving some H2OC undissociated. This makes carbonic acid a weak acid. A base is defined as a solution that has higher hydroxide ion concentration relative to their hydrogen ion concentration. When placed in water, it will be pulled apart by the polar water molecules, releasing positive sodium ions and negative hydroxide ions. This increasing OH concentration makes it a base. In fact, just like HCl, NaOH is considered a strong base. Almost all of the sodium ions and hydroxide ions will dissociate in water. Lithium hydroxide, on the other hand, will dissociate into water to become free lithium ions and free hydroxide ions, but not all of it. Some lithium hydroxide will remain in solution, so it's considered a weaker base than sodium hydroxide. The pH scale is used to quantify acids and bases using hydroxide ion concentrations of solutions. The scale ranges from theoretic values of 0 to 14, where acids are below 7 and bases are above 7, while pH 7 is neither acidic nor basic, it's a neutral substance. The scale is based on a power of base 10. This means that an acid with a pH 1 is not just 2 times stronger than an acid at pH 2, but rather 10 times stronger. A buffer is a weak acid that is not fully dissociated in water. Remember hydrogen carbonate? When placed in water, some of it dissociates into hydrogen ions and hydrogen carbonate ions, but not all of it, because it's not a strong acid. Let's focus on some of the hydrogen carbonate ion floating around. If we add some hydrogen ions, essentially adding more acid, the hydrogen carbonate will bond with some of it, locking up as H2CO3, essentially eliminating the free hydrogen ion, which means no change in pH. This is what a buffer does. It buffers pH change by removing free hydrogen ions that are added to the solution. Now remember, when H2CO3 is added to water, not all of it dissociates. Some of it remains as H2CO3. This H2CO3 is able to respond to the increasing OH ions when a base is added. It dissociates into H ions and HCO3 ions. With the addition of the OH ions, the solution becomes more basic, but with the release of hydrogen ions as a response from the H2CO3, it also becomes more acidic, essentially neutralizing each other out. You can visualize this as the OH added from the base combines with the H plus ion released from H2CO3, forming water, which is neutral. So when a base is added to a buffered solution, the buffer releases a hydrogen ion to tie up the OH, this limiting the pH change.